Hello students, welcome back to my YouTube channel Mathematical Lens by Namita. In this video, we are going to revise chapter number 2, linear equations in one variable of grade 8 from the old NCRT textbook. Okay, then old NCRT textbook of grade 8, right? So first, to understand what are linear equations, we will revise what are algebraic expressions which we have learned earlier, right? We should know the difference between an expression and an equation. So if I give you examples of expressions, like if we take 2x minus 3 is an expression. It has constant, 2 and 3 are constant, and x is a variable. So expression will have a constant and a variable. Like we can take another example, 3x plus y. So this one has 3 as constant and x and y both are variable. So these are expressions. They are not equations. Now let us see example of equations. So if I take, suppose 5x plus 25 is equal to 30. Fine. So here there is an equal to sign that you need to note. So you have a variable, you have constants, and there is an equal to sign. That's why it is known as equation. We can take another example like 2x minus 3 is equal to 9. This is another example of equation. So what is important is it should have an equal to sign. Also, linear equations in one variable. So we are learning only one variable in this class. So you can see there is only one variable x. The variable can be y also, like 3y plus 1 is equal to 4, suppose. So here y is a variable, but there will only be one variable. Okay, so you should understand the meanings of one variable. What is equation? Now what is linear? Linear means where the highest power of the variable is 1, right? So here power is 1. Here also nothing is written, means the power is 1. So if we take examples of equations which are not linear, so then it would be like, for example, x square plus 1 is equal to 1, or y cube plus 3 is equal to 7, right? So these are not linear. Means you can see the power of the variable here, it is 2, 3, like that, right? So what is important in a linear equation? If we take one example, a 2x minus 3 is equal to 7, there should be an equal to sign. That is important. Then the variable with power 1, and these are the constant. 2, 3 and 7 are the constant. So this is a linear equation with one variable. Now a linear equation with a variable will always have a solution. Solution, what we say, the value of the variable. Solution, it is also known as the root of the equation. The answer which we get, the value of this x which we will get, it is known as the solution of the equation or the root of the equation. So these are basic things which you need to understand about linear equations in one variable. Now, how to solve this linear equations, right? So let us understand it through various examples, right? So if I take the first example of your textbook from the exercise, I'm taking the first example from your exercise, that's the simplest one. Then I'll take few complicated ones also. So first you need to understand in the equation, this is LHS, this is known as LHS, the left hand side, and this is known as RHS, the right hand side. Okay, so we need to transpose. What is it known as transposition? Transposition, we take the variables together and the constants together, right, on one side, either on the left side or the right side, and then we solve it and find the answer. So here you can see that 3x and 2x both have variables. Now, while bringing them on the other side, when we change, it is known as transposition. We transpose. So we keep 3x over here and we bring 2x on this side. So the sign will change. So what you need to remember, if it is a positive number, then it becomes negative. If it is plus, it becomes minus. If it is minus, it becomes plus. Similarly, if it is multiplication, it becomes division, and division becomes multiplication when you transpose one number from one side to another side. So we bring 2x here, it becomes minus 2x. 18 is already on that side, so it will remain as it is. Now 3x minus 2x. What is 3 minus 2 is 1. So we just write x. We don't write 1x, we just write x. So you can subtract only the same variable, the numbers with the same variable. So 3x minus 2x, they should be like. So the value of x is 18, right? This is a simple question which I have taken. Now we'll take the second question. 5t minus 3 is equal to 3t minus 5. Now, just see, on both the sides we have numbers with variable and constants also. Right, so what do? We take both the constant together and the variables together. So if we keep 5t here only on the left hand side and we bring 3t on this side. So 3t is plus 3t. So when we transpose it, it becomes minus 3t. Okay, remember this step is equal to sign. Now minus 5 is already on RHS side. We are not changing its position. We are taking 3 here. Right, so minus 3 becomes plus 3. This you need to remember while transposing. The signs should change. Now they are like, so we can subtract. So 5t minus 3t. 5 minus 3 is 2, so this becomes 2t. And minus 5 plus 3 is minus 2. Sign of greater and two different numbers means subtraction. So 5 minus 3 is 2 and we put the sign of greater. Now 2t means 2 multiplied by t. So when we take this 2 on the other side, it goes in division. Right? So t is equal to minus 2 upon 2. So 2 upon 2 is 1, but there is minus sign. So the answer will be t is equal to minus 1. Now I will explain you question number 9 of 2.1. I told you I'm taking different types of example. Here you can see there are fractional numbers. Right? So how to solve fractional numbers? So first thing is identify the like terms. You can see 2y and y, these are like terms, so we bring them together, and these two are like terms. They are both are constant. So what do? We keep 2y over here and we bring minus y this side, so it becomes plus y. Okay, now we put the equal to sign. 26 upon 3 is already on the right side, so we'll write it as it is, and we are taking 5 upon 3, which is a constant, on the other side, so it becomes minus 5 upon 3. Right, now 2y plus y is 3y. Okay, now here you can see if it is a fractional number, you have to find out LCM. Here they both have same denominator, so 3 will be the LCM, and you can directly subtract 26 minus 5. So 26 minus 5 is 21 upon 3. So first we solve it. So 3 ones are 3 sevens are. So you get 3y is equal to 7. Right? Now we need to find out the value of y. But there is 3 along with it. But 3y means 3 is in multiplication. So therefore y will be equal to 7 is already in the numerator. This goes in denominator, that is in division. If it is multiplication, it becomes division. So your answer is y is equal to 7 upon 3. Now I am taking one example from exercise 2.2, question number 6, where most of the children get confused while solving, right? So I'll explain this question. Right? Now you need to, first of all, why you get confused in this, you need to identify the terms. So how many terms are there? Terms are separated by plus and minus sign. Remember that. So this is one term. This is second term. This is together. So you can't think this minus sign. So this sign is separating these two terms. So there are two terms here and there are two terms on the right hand side. This is one term and this whole is together. So it is the second term. Right? So once you identify the terms, you need to first find out LCM. So if we try to find out LCM here, there is nothing means 1, okay, upon m upon 1. So LCM will be 2. So this will be multiplied by 2. So it becomes 2m. Right, here already 2 is there in the denominator. So we need not multiply anything with this term. But the most important part is put minus sign and put m minus 1 in bracket. Because here is when children make maximum mistake while solving it. Okay. Same thing we'll do over here. We take 3 as LCM. Here nothing is there means 1 upon 1. Now 3 is the LCM. So 3 will be multiplied with 1. So this becomes 3. Again, take care that put a minus sign and put m minus 2 in bracket. So this is the most important part. Now while opening the bracket, you know that we change the sign. So this becomes minus m and minus into minus becomes plus 1. Right? Similarly here, 3 minus m and minus minus plus 2 upon 3. Okay. Now we see there are like terms. First we try to simplify it. So 2m minus m becomes m. 2 minus 1 is 1. So m. And this plus 1 remains as it is. They are not like terms. So we cannot touch them upon 2. Okay. So we just solve this part. Now here the like terms are the constants. So 3 plus 2. Don't see this sign. This is for m. So 3 plus 2 is 5. Minus m upon 3. Okay. Now, once you have simplified, you can do cross multiplication. So 3 will be multiplied with this LHS side and 2 you can multiply with 5 minus m. Okay. 2 goes this side, cross multiplication, 3 with m plus 1 and 2 with 5 minus m. Now I told you earlier also, whenever you are multiplying a number with terms in the bracket, multiply with both. So 3 into m is 3m and 3 into 1 is 3. Okay. Here same way, 2 5s are 10. 2 also multiply with m. So 2m, and don't forget the sign, minus sign. Now we do transposition. We take the like terms together. So we keep 3m over here and we bring 2m on this side. So it is minus 2m, that becomes plus 2m. Okay, go stepwise. Is equal to 10 is already on that side. So write 10 as it is. And we are taking 3 on the right hand side. So the sign of 3 is plus, it becomes minus. This care you need to take while transposing. Okay, so 3m plus 2m is 5m. Correct? And 10 minus 3 is 7. So we added the like terms. Finally, m will be equal to 7 upon 5. This is, again I am repeating, 5m means 5 into m. So it goes in division. So the final answer is m is equal to 7 upon 5. Now question number 10 of your textbook, where there are decimal numbers, right? So children get scared when there are decimal numbers. So there are two ways of doing it. Like you can keep the decimal number as it is in the decimal form and just multiply them, or you can convert them into fractional form. So I'll teach you both the ways. Whichever way you find it easier, you can do it that way. So first let us keep them as it is, like in the decimal form. So if we multiply 0.25 into 4, now 25 fours are 100, right? Now there is after decimal point, there are 2 digits. So before 2 digits, you will put a point, so it becomes 1. 25 fours are 100. So that becomes 1.00, that is 1. So this becomes 1f. 1f means 1. Okay. And you will multiply 0.25 with 3 also. So 25 3s are 75. But we need to put a decimal point. So 0.75. Just see that the decimal places are same. Is equal to. Now we multiply 0.05 into 10. Now when you multiply it by 10, what happens? We just shift the decimal point on the right side. Okay, one jump. 10 means one jump. So 0.05 becomes 0.5 and there is f. The variable is f over here. Then we multiply 0.05 with 9. So 9 fives are 45. And don't forget to put the decimal point before 2 digits, right? Because here there were 2 digits after decimal point. Okay. Now we take the like terms together. So F, 1F, I can write 1F, and this comes on this side 0.5F is equal to, this is minus 0.5. Just take care of that. It is already on the right side and there is minus sign, so we keep it as it is. And minus 0.5 comes on the right side and becomes plus 0.75. Okay, this 0.75, we bring it here and it becomes plus. Now 1 minus 0.5 is 0.5. F is equal to 0.75 minus 0.45, right? So that becomes 0.30. Okay. Now what do? We convert them into, we can write 0.30 or you can just write 0.3. So 0.3 upon 0.5. Got it? So you can just strike off the decimal point because they are like decimals. So the final answer will be 3 upon 5. Okay. This is when you don't change them into fractional number. So the final answer is 3 upon 5. If you want to write it in decimal form, then the answer will be 0.6. Okay. How do we get 0.6? If you want, I can explain. 3 divided by 5. Take a decimal point and then take a 0 here. So 5 6 are 30. Okay, because 3 is smaller than 5, so we take the decimal point and we take 5 6 are 30. So it is 0.6. Now the same question, if we convert into fractional form and try to do it, what will happen? Let us see. Same question I am writing again. So 0.25 to 4f minus 3 is equal to 0.05 into 10f minus 9. Now we convert it into fractional form. So 25, 0.25 becomes 25 upon 100 because there are 2 digits after decimal point. So 100, and we write other things as it is. First we are converting it into decimal form. Now this becomes 5 upon 100. Again the same thing, there are 2 digits. Now you can see that these are all, this is one term, this is also one term, and upon is 100. So when the denominator is same and there is a single term on both the sides, you can strike off these denominators. This 100 and 100 can be striked off. Why can you strike off? Because if I take this 100 here, it will be in the numerator. So then you will be able to strike off 100, 100. So what is left is 25, 4f minus 3 is equal to 5, 10f minus 9. Now this becomes easy, right? So we multiply 25 4s are 100f, 25 3s are 75, 5 10s are 50f, and 5 9s are 45. Okay, we take the like terms together. So we put a therefore sign before each step because there is already an equal to sign. So you cannot have two equal to sign in one line. So 100f minus 50f and minus 45 is already on that side. Minus 75b, transpose it on the right side. So it becomes plus 75. 100 minus 50 is 50f. And 75 minus 45 is 30. So f is equal to 30 upon 50, right? We bring 50 in the denominator. So we can strike off 0, 0. So the answer is 3 upon 5. How to convert it into decimal, I'll teach you another way over here. There I divided and showed. Here what you can do, 5 2s are 10. So we multiply both by 2. Okay. And so that it becomes 3 2s are 6 upon 10. That is equal to 0.6. So the value of f, the solution or the root of the equation is 0.6. Thank you.